Cool. Welcome all to August's Remix Bay Area meetup. Tonight's speaker is Sébastien, and he'll be talking to us about Remix and high performance e-commerce using the Crystallize API. Before we jump into that, I just want to say a few words. Welcome everybody. If this is your first Remix Bay Area meetup, welcome back if you've come here before. If you would like to give a talk at a future Remix meetup, there is a form document, and I'll post it in the Zoom chat here. It is also on our meetup page. It's just a quick Google form, basically your name, the talk idea, description of it, and how we can get in touch with you. That helps us keep these talks organized. It makes it super easy for us to get these going. So if you've got any topics, Remix related, maybe a project you're working on, something you're thinking of using at work, side project, personal blog, anything like that. Remix is a fairly new framework, and there's no super high bar that you have to be some wild Remix expert in order to give a talk here. So it's really open for everybody. So please check that out. I'll post that in the chat here as well. Yeah, be sure to check out, we've got links to our Twitter and links to our YouTube as well on our meetup.com page for this group. Twitter's, we don't post anything really except for about upcoming meetups, so it's a nice way to get announcements there. And YouTube is for all of the past meetups. We post the recordings usually within a couple days. So yeah, without further ado, if there are no questions for me, I'm just going to hand it over to Sébastien.
Hello everyone. First, thank you for having me. That's great. I think it's one of the first meetup I'm doing after COVID. I've done some before, but so that's cool. It's good to be here. It's good to talk about Remix. So we're going to talk about Remix performances, HTTP cache, and e-commerce. I have slides. We are going to do some coding as well, but please don't hesitate to interrupt me if you have questions. We are not at the conference, so that's a good moment, I think, to ask questions and share the feedback. So you don't hesitate, you are using the chat. And yeah, we can keep your question for the end as well, of course, but yeah, don't hesitate. So I'm Sébastien Morel, I'm CTO at Crystallize. You can hear, I'm French, impossible to lose this accent, so that's it, but you're gonna adapt to it. So yeah, I've been a backend developer for a long time now. I moved to California 8 years ago, and I love open source, and I love performances as well. And at Crystallize, we are actually providing an headless e-commerce, SaaS headless e-commerce. So it's a toolbox. It's a toolbox to help front-end developer and our customer to build their front store, their storefront, on top of APIs that are really fast, and on top of UI, because we're providing an admin UI, you're going to see it. That is really, I would say sexy. So it's a backend as a service, kind of, as we can say. And we're providing API to manage your order, to manage your product, to build the catalog, to manage subscription. We have also an asset organizer. And we're taking care about the video, transcoding, the image conversion. So it's really everything that you need to build a good front end. But we're going to come back on that. But yeah, it's a complete e-commerce layer. And talking about performance, which is the second persona that we really like to focus on, it's persona. How do we build an experience good enough for our customer with performance, because it's one of the goals, right? If the performance are not there, then the experience won't be good. So first, we have something that probably you've heard about, right? The core web vitals, a lot of different metrics that you can get to make sure that your front end is actually fast enough, that you are not blocking the UI, that the image are lazy loaded, that they are correctly sized, that it's interactive really quickly, whether you are on desktop or on mobile, the blocking time. So all of that stuff is really important, and they are not the subject of this talk. I wanted to mention them because those are really, really important. And when you release a project and you want performances, especially in e-commerce, problem with e-commerce is it's not a problem, but the performance equals revenue, right? The faster your website is able to take orders, the better it would be for your business. So those are really important. The focus of this talk is about Remix. And Remix, I hope you know Remix if you are here, right? As something different that other frameworks might not have. When I talk about, if we talk about Next.js and, Gatsby and all those server as our static site generation system is on Remix, you have a server. And if you have a server, this server must respond really fast as well, right? So we're talking about Remix because it's cool, and we're going to see why it's cool and why it's really performant. And we are going to go even further, how to make Remix even faster than it is using HTTP cache, HTTP2. We're going to talk about that a little bit. And we're going to see all the tricks that you can use to make an e-commerce website really fast. Of course, to test those, you have tools to test your performances. So this is two of the tools that I'm using. It's Web Patch Test and Google Patch Speed, of course. So that was just to mention them. And also because Henry registered for this meetup, but I don't see him, or maybe he has arrived. Yeah. So yeah, two very good tools to test the performance. So what about e-commerce project? Why are they so different? Why, you don't manage an e-commerce website the same way you manage a website, a blog, right? Where you just display content. Why? Well, because on an e-commerce website, almost everything is dynamic. Almost. The catalog with the price, you have product variation with inventories and stock. Pricing, you can have different pricing depending on who is logged in B2B. This is really something that is happening a lot. You have sales, a private sale. You can have discounts, count code. And on top of that, you have the search that must be up to date with all those dynamic variables. And of course, at some point, when your catalog is built, the checkout is done, the payment is received, you need to manage the order behind the scene, right? So all those key features of an e-commerce website makes it kind of more complex than a blog or a website where you just display content. And yeah. So this is where we are kind of back to the web standard. And this is something that you might hear a lot coming from Remix is you need to embrace the platform. And this is what they've done, right? When you are doing a form with Remix, you don't do some kind of fancy usage of a library. You just submit a post request to the browser. The browser is submitting it to the server, but it's back to the basics, really back to the basics. So when you're building an e-commerce project or any kind of project, you need to think about how are you going to handle the rendering? Are you going to use server-side generation, static server-side rendering, static site generation? Are you going to do a single page application? This is a choice that you have to make. And I'm going to talk about that right after. Then you need some kind of strategy to handle the cache. We're going to talk about HTTP cache and application cache. And of course, at the end, you need some kind of architecture to make sure that you can scale. And this is also something we're going to see at the end. So in terms of rendering, what are the strategies? Well, you probably know what is a static site generation system like Gatsby or Next.js, or if you are using Golang, you have Hugo, you have many of them. The approach of those products is you pre-build everything at build time, and everything is static after that. Almost everything. Of course, you can have Lambda function and stuff like that, but your pages most likely are going to be static and hosted somewhere, Vercel or Netlify. And every time something is changing, then you need to rebuild. Of course, you have a webhook, it's all automated, but you have a time where you need to rebuild the project. Now imagine in an e-commerce situation where you have I don't know, it could be quick to have a million of different variants with pricing if you are doing a multi-currency and multi-store project. Imagine that would be a rebuild, a never-ending rebuild. You would rebuild on every change, every price change, everything. So this is not really adapted for e-commerce project. An SPA, on the other side, might have some advantage here in terms of making things dynamic, but that would be really bad for SEO. And also, an SPA, it's not that great because, yeah, you still have to download the full application, the first load. It's not that great. And then the third one is the server-side rendering, where, yeah, that's great, but everything is rendered server-side, and every time you click somewhere or you submit something, that it reloads the pages, and then you load way more resources than what you need. What would be great, it's a mix of the three, right? And this is why Remix Run has so much traction right now, because they found a way to make it progressive, right? So with Remix, and you probably know that, we're going to see some tests, but yeah, the first load is server-side generation, and everything afterwards is kind of a mix of an SPA / static site generation. So this is why for us, Remix is awesome for e-commerce. It's a perfect fit for e-commerce. So let's dive into it and into a little bit of demo and a little bit of HTTP cache. So I've prepared a little demo application for you, a very simple one that I'm going to run. So we're going to look at the code. So a very simple application where you have a home page, simple. You have a shop that lists products, and you have a product page. And on the product page, you have all the variants you can add to cart. That's it. That's all we need to discuss about HTTP cache and stuff that I want to show to you today. A little bit of presentation. We were talking about Crystallize behind the scene to do this quick example, this quick project. I'm using Crystallize. So Crystallize, it's an headless SaaS e-commerce GraphQL API. So we're providing everything you need to build the front end. So you just have to register, nothing to install, then you can start to build your catalog. So here, what I've prepared, it's a very simple shop. So see the content are structured as a content tree, so you can have as many levels as you want. And I've created some donuts for you. I know it's not yet the time to eat, but kind of. So, you know, this is how you will edit product into this admin UI. So this is focused on product storytelling. So again, Crystallize, it's kind of a CMS plus PIM plus order management system. And we want the marketing people and the sales people to be happy with what they are doing. So they arrive on this view, they can edit the product storytelling. They can go and edit each variant, provide the prices, the different attributes, the stock level. They have a more nerdy view if they want to edit a lot of prices at once. Of course, it's multi-pricing, tax, and of course, as well, you have the preview. This is more for the developer, for the marketing people here. So we're trying to make that sexy. And for us developers, you have this view where you have access directly to the data. So here it's an access to this product through the GraphQL query. So if you've used GraphQL before, you know what it is. GraphQL is really cool to ask only what you need. So if you just want the title, you can just get the title, etc. and etc. So this is the system that this application, demo application is using. So we are fetching data through the API to render the website. Just to, briefly show you what Crystallize is. Of course, on top of product, you can have topics. So it's a way to associate product, aggregate products, search, filter. We have that. We have a concept of grid. So you can kind of merge the two worlds. This is an headless API thing. So we don't render anything, but still the marketing people, they want to build grids. And those grids, they would expect them to be rendered in a certain way. So this is what we have. We have a very cool interface where I can build, very complex grid. And then you can just, drag and drop to the product, to build the grid. The result would just be a grid, like here. So this is how we do that. And of course, we have the digital asset management. The order, you can take orders. You have order fulfillment pipeline if you want to trigger. It's a state machine basically on API. So an order can go through pipelines, change stage. Then you can listen to webhook to trigger actions, etc., etc. It's enough for the demo. We can discuss Crystallize if you want. But yeah, this is of course MBS, but yeah, it's a good product to build e-commerce. And we are managing subscription as well. So you can build subscription plan on top of it. So enough of this. If you have questions, you don't hesitate. But so this little project is asking the data from Crystallize. So now let's deep dive into the code. This is the last version of Remix using React 18. And I just want to show you the initial state. It's probably, if you have never done HTTP cache on top of Remix, the boilerplate that you can probably get by yourself. So this is the home page. Go to shop. You see very, very simple page. Then we have the shop, which is actually fetching the product, right? So very simple. This function is actually there. We're just doing a GraphQL query to get the product, to get many products, okay, and randomly, and we display them. So it's Remix, so it's just React here. And then we have the product page, which is actually fetching a specific product. So it's another GraphQL query. And we render the product here, right? So of course, we have some styling to make it cool and beautiful, even though it's not that beautiful, but it's enough for the demo, right? So for the shop product page, this one was the shop page. And let's have a look at how Remix behave by default, which is really cool right away. So let's have a look at this. I hope the size is great. And let's see, I reload the page and I'm disabling my cache here, right? So I will load the first page, then I will clean my tab and I'm going to go to shop. And I'm going to look at what's going on. Here I have some JavaScript. I have some images. I'm going to clean again. And you see all are loaded, right? They are fetched, of course, from the server. Then I can click on the product page. I have a few more resources that are loaded, this JavaScript and another image, of course. If I clean that again and I go back, nothing specific has been loaded here. If I go back to the shop, I have something, some other images and some data. And if I go to the same product, again, some data, right? What is important for me are actually the data. As you might see, every time I go back to a page that is loading data, every time it is fetched, right? So every time you click on the page, of course, it doesn't reload the page, obviously. So it's kind of fast already, but those data will be loaded. And you cannot expect that, right? Because if I change the page, I will expect the system to fetch this data that is specific to that page. But maybe it's not, maybe it didn't change. So why would you download some data that you have if it didn't change, right? And this is exactly the purpose of HTTP cache. It's the server would decide how long the browser or the reverse proxy, So you need to know what is a reverse proxy or a CDN. Of course, so reverse proxy, you might have a Varnish. A CDN, you have Fastly, Cloudflare, Akamai, all those components. They are somehow between the browser and your backend. And they are here to kind of protect your backend by being a layer of cache in the middle. And the browser acts, and they respect HTTP cache. So HTTP, it's a protocol, and you have rules and specifications, and the browser is respecting HTTP cache as well as proxies in general. So let's see how we can optimize this with Remix to enable HTTP cache, right? So how do we do that? So HTTP cache, let's come back to the slide first. So here we go. So HTTP cache. First, when you do HTTP cache, you can decide of short TTL. TTL means time to live. You can have short TTL, so you can say, okay, I'm going to put that page in cache for 5 minutes. Then every 5 minutes, it's going to be fresh, kind of again. This is cool. This is not optimized, right? Because maybe after 5 minutes, nothing changed. So why would you do that? The goal is to reach 95% of hit ratio. What does that mean? It means that you're gonna hit the cache 95% of the time while being 100% dynamic. This is kind of crazy, but this is totally achievable. And we're gonna see that together. So the goal is to have long TTL on the server side, which means on the reverse proxy side. And because you cannot control the cache in the browser, usually in the browser, you're going to get short TTL. Because again, in the browser, you cannot clear the cache of someone remotely. So how do we do that? So first, we have 3 situations with Remix. Again, this is specific to Remix now. It's HTTP cache on top of Remix. So first, we have the data loading, the stuff that I've showed you. When I change pages, Remix is fetching the data and only the data that is needed coming from the loader, right? Then I have the first page rendering when everything is rendered. So you get actually HTML and not JSON. And then we have the page chunk. This is the script.js, those things that we've seen together before. So we might want to cache those in different ways. First, the page chunk. This is kind of cool. We're going to see that together, but by default, Remix is handling that for us. Those chunk scripts are immutable, and that makes so much sense, right? It's part of the build. They will never change. It will change the next time you deploy, or the next time you're deploying a new application, because the code of your application is going to change. But nobody's going to change the code remotely unless you are deploying. So those pieces of information are actually immutable. Once your browser or the reverse proxy gets it, that will be available and will be always the same. And if you deploy a new version, the name will change. If I switch back to this application and I do exactly the same to have a look at those ones, I need to disable the cache. Look at those ones. Chunk something. Those are immutable, of course, because again, they don't change. Of course, I disabled my cache, so they're coming back. But if I do that, they're not going to come back. So I hope it's clear for you. It makes so much sense. They're immutable because they're part of the application. So if I do that, you don't see them anymore. The only thing that you see are the data loading. Cool. So that's one situation, the page chunks. The other one is the first page rendering. How do you cache that? Remix doesn't know if this page must be kept in cache for 60 seconds, an hour, or 5 days, right? You have to instruct Remix, your web application, to tell the consumer, which can be the CDN or the reverse proxy or just the browser, how long this component, the caching component, can keep the page. And to do that, you are using cache control. For the more advanced people of you and HTTP cache, you have two models, validation and expiration. The validation model, it works with e-tag and last modified, but it's not really cool to use because every time the browser is asking the server, hey, do you have something new for me? And if the server is answering 3 or 4, it means that, no, I have nothing, but you eat the server every time. So we don't want to eat the server. We just want to eat the cache. So we are going to use the expiration model, which is the best in many situations. So, and you want that by cache control. So here I'm saying, yeah, this page is public. You can keep it in the browser 60 seconds, and you can keep it in the reverse proxy for an hour, right? Cool. This is for page render. We're going to see that in action. Then for the data loading, it's kind of similar. It's in the loader. You're going to fetch the data, and you're going to say, okay, please keep those data available in your browser for 60 seconds or in the reverse proxy for an hour. And of course, and you should be careful here, you also need to do that on the page level, because remember, the first time Remix is going to do both. It's going to load the HTML, and to load the HTML is going to need the data, right? And those data are controlled by this cache control. This is why the trick is to ask Remix to load the cache control of the loader. So the first time you get a good cache control. So let's see that in action. So I'm going to just switch branch. I'm going to go to the HTTP cache branch. I'm going to make serve. And we're going to have a look at what has changed. Oh, we have a question. I'm going to have to cut the rest of it. Good, thanks. Cool. So, so here we just have exactly the same as what we have in the slide. An header and home page, an header on the shop page, and a header on the product page. So now I come back to my browser, and we do exactly the same. I'm reloading the page. I'm looking at this. I'm going to disable cache for now, and we're going to have a look at the header. So here you can see where am I? Product page. Looking for the cache control. Sorry. Looking for the cache control. So here we have public max age 60, etc., etc. And we have exactly the same. We should have exactly the same for the loader. For the loader. Yeah. Okay. Cool. Awesome. Great. So now let's see. I'm going to re-enable the cache. I'm going to do exactly the same. I'm going to clean that, and then I'm going to browse my website. Here, I'm loading the data from the server. Of course, this is the first time. Then I'm going to fetch this page. Of course, this is the first time. And then I'm going to go back, and we're going to do exactly the same. And here, what you can see, of course, it's loaded, but from where? From the cache, from your browser cache. I'm just on my local, right? So I don't have any reverse proxy or CDN, but that would have been the same. It would have been cached in the CDN. And that's going to be cached for 60 seconds, as it is mentioned in the header. Of course, right? If I go to a page where I didn't go, that's going to be fetched. But if I do that again, it's going to come from the cache, right? So I think you got the point. You can enable the caching this way. Cool. We have HTTP cache. Nice. Our website is really performant, right? But it is not dynamic at all, because everything is cached, and you need to wait for a long TTL to get something expired, right? So how do you make it dynamic? We make it dynamic using a concept that is called event-driven HTTP cache expiration. What does that mean? That means that your backend must be able to instruct the caching layer saying, hey, please, can you expire this? Because I know it has changed. So you actually purge the cache from outside. And how do you do that? Are you going to provide a URL? Yeah, might be complex because it could be loaded by a loader, right? So do you provide a set of URL or a pattern of URL? Actually, no, you don't do that. You are using headers. You're going to use HTTP again, and you're going to tag your response. This is a key. This is a trick. So here I'm going to do exactly the same thing as before, but on top of that, we are putting some keys. So depending on the cache layer, the keys, the key, the header, right? The header that is receiving the keys might change. Surrogate key is for fastly, for instance. X key it's for varnish. So that you have to read the doc to know how to do that. But then I'm tagging those response. And then I can instruct my my HTTP cache layer to purge this. So again, one more time, in action, I'm just going to do check out HTTP tag HTTP. Boom. So this is exactly the same. But I have one more key. So the trick here in a real life application is you fetch a product and you put the product ID, right? So then you can say, okay, please expire all the HTTP response that includes product 65. And everywhere you have a loader that returns a response that has been tagged with product 65, then it would be expired. And you can be smart. You can put product and I don't know, some kind of tags here or labels or whatever. You can add as many keys as you want, so you can control the expiration. So here I can say, please expire all the HTTP response. I mean, all the response that you have in your cache that are tagged product. So all my product page will be expired at once. So it's a way for me to expire some part of my website and not the other. So this is a way to expire only what you want. Of course, you need an header. If I take the example of Crystallize, here we have a fastly cache purge. So we are actually listening to an event. So when something is published, then we're coding the webhook, and actually behind the scene, this webhook is going to call fastly and say, yes, please get the ID of this product and expire all the pages that are connected to this product. So this is really performant because you just expired what you need and when you need it. Cool. So that's it. So to sum up, chunks are immutable per build. SSR page are going to be tagged and cached, and you have a mechanism to trigger purge on updates. And updates could be anything, right? When you update the stock, yes, that's an update. So you can expire what you need to expire. But then what about user specific? How about you are in a B2B situation and this client has 20% off because it's a really good client. How do you manage this? Well, there is no tricks here. There is no things that you can really do to make it perfect. Of course, that could be the subject on another talk. You can do HTTP cache based on the user context, but this is kind of complex to put in place. Here, it's simpler, and also because we have Remix and we have optimistic UI. Yep, the simplest way is you load the pricing that is available for everyone, and it's cached, so it's fast, and you enrich the UI with specific prices afterwards. And for that, you use a fetcher in Remix. So you bypass the cache kind of. So if the user is authenticated, you send a request afterwards to get the specific price. So that's the tricks here. The trick. So that's kind of it for HTTP2. Then for performances as well, you can use HTTP server push you also, and now it's going to be replaced with the HTTP 103 partial content, if I recall, but it's really similar. It's based on the header. That's why I wanted to show you that. Actually, HTTP2 is nice because when you are using HTTP2, you can instruct the server to send more than one request into the response. And the browser is going to understand that and load everything without asking the server again. So for instance, when I put that in an header, the browser is going to say, oh, okay, in that response, I am also going to get the /css/tiles.css. So I'm not going to ask about it because I know it's going to be in this response. So I can get it right away. What that means that you can provide a lot of things in the first response. And this is how you do that with Remix. You just add an header link with, for instance, your style sheets of Tailwinds, and then it's not going to be fetched. It's going to be pushed to the browser at the same time as the HTML of the page is pushed to the browser. And because now you know how it's working with everything that we've seen so far, why not pushing all the chunks? You could push all the chunks in the first load, so the browser doesn't have to ask them all to the server, right? To push them all into the first request. So, you know, it's really fast. How would we do that in action? Let's see that in action. So I'm going to go to that last branch, HTTP server push, and that time it's a little bit more change because we need to serve HTTPS locally. So just for the sake of the recording, what happened here is now we have a CADI file that handles HTTPS for us, and I have a HTTPS certificates that are local anyway. So now I have HTTPS, and in the code, well, as in the slide, link, I get the parent, of course, and link. Yeah, no, I didn't do it here, so it's just here. So let's see what it does on the browser, which is the most exciting part. So Remix. So this is local, right? This is on my local computer. And now I'm going to cache is enabled. When I go to the network tab and I reload that page, where am I? Sorry, I want to see everything. I'm going to clean that. I'm going to reload everything and see here cache. When I load this page, here you can see push. Some are cached, of course, the images and the chunk. Some of the chunk, but some are pushed. So it means that they were not downloaded, they were pushed at the same time as the shop request. And actually, why? Because the header includes them all. So this is a way with Remix to push all the chunk in the page. Cool. Enough of that. I think it's clear. So if we continue, we were talking about the HTTP cache, and it's not enough because sometimes you might want to have also application cache, right? When you're building e-commerce, a very good example is the inventory management. Sometimes you might have more than one warehouse, but let's imagine you have only one. You need to manage this inventory, and usually the trick is to get the number of SKU that you have on hand. Let's say you have 25, and then people might have paid or might have reserved some of them. This is the on hold, and then on the storefront you will do the subtraction, right? So what you have on hand minus what you have on hold is actually what is available. So on hold is actually application cache, because you could get it. You could fetch all the orders that are being done, compute the stock, and then do the subtraction. But that would be not good at all in terms of performance, because every time you want to get the available inventory, you will have to do that big query. So instead, it's way simpler to have another variable in your database, or in Crystallize, we have that by default. You have somewhere to put it on hold, so you don't compute anything, and you can render the website in even faster. And the last, but not the least, architecture is important. Doing those things are kind of slow if you do them synchronously. It's the same as using promises somehow, right? If you do that, if you do await, you accumulate those waiting time. So database insertion, payment checking, email, stock update, cache expiration, and third-party services call, you can end up with a page that is doing stuff. When you place the order, the user can wait for 1-2 seconds. This is not good. Instead, either you are fine with promises and you trust your node server, or you want something a little bit more robust, and you would use workers and queue, like RabbitMQ or AWS SQS, and you would build an architecture a little bit like that, where you just place the order in the database or in Crystallize, then you send a message to the queue to trigger those actions, and those actions will be done asynchronously behind the scene, and they don't make the website slow. It's kind of obvious, but it has to be mentioned. So in conclusion, and to wrap up, a key to good performances is using the web standard, thank you Remix, using HTTP cache, HTTP2 with expiration method, much better and much more efficient. Also, something that I like to mention for every developer I'm working on, and in my team, it's cache is part of the application. This is not something that you put at the end. Full cache should be enabled on staging, on pre-production, or whatever you call that. And you should also run your functional tests on top of a cached version. So in the CI/CD, somehow you need to figure out a way with Varnish, Docker, and everything to have HTTP cache, because it is part of your application. It's not just a shield on top of something. That's an advice from me. User-specific data can be fetched afterward. You can enrich using optimistic UI, or just a fetch afterwards. And asynchronicity, can I say that maybe, is really key, because the more asynchronous you are, the more scalable you will be. Kind of obvious. You can scale horizontally if you have workers. So this is usually something that you want to do. That's it. We're organizing React New York on February 24th. It's kind of cool. We're talking about many different things. It's not focused at all on Crystallize, but we are organizing it. Come, let's have a beer there, right? Or a coffee. That's it for me. Of course, we are providing boilerplate and libraries to speed up the time that you would need to actually build a project on top of Crystallize and Remix. We have a very cool Remix boilerplate that you can use. That's the time for the question. If we have some question. Thank you for listening.
That was a great talk. That was just like a great deep dive too into just caching in general. Adrian, did you have a question?
Hello. Yeah, I was trying to unmute myself. First of all, thank you, Sebastian. It was a very cool talk. So I was wondering if we could have access to this demo repo, like so that we can see the code or even the slides. Like it will be.
Sure. Yeah, I can send it to Eric afterwards, and I can push the code somewhere. Regarding the boilerplate that we have with Remix, we have a set of boilerplate with different techno and frameworks. The last one is this one furniture Remix, but it is fully functional e-commerce storefront based on Remix. So this one is kind of cool as well, but I can provide the link, and maybe Eric, you can put them somewhere on the meetup.
Sure. Yeah, I'll send them out after the meeting, and I'll put them on like a link in the YouTube video as well of the recording.
Okay.
Cool. And my other question was that, well, maybe you didn't went too deep into the QS for parallelizing, like the other ones. So it means that you're starting like a web worker, and each one of those web workers is going to do those tasks.
Yeah, so here you have different ways of managing queues, right? You might have one queue, many queues. The trick is the website should do nothing most of the time. You push something somewhere, and this is what we do with Crystallize. So you push something to Crystallize, then you trigger a webhook, and then you set up a webhook, and then the webhook is going to call another API endpoint, which is not on your server, which might just be a Lambda function somewhere. So what you want is you want to save the computation work and job on your web server. You don't want the web server to do anything. This is the way you scale horizontally. So you have many ways, and workers are ways of doing it. If that answers the question. So you can have a queue to send email and stuff like that.
Yeah, so you were not. Yeah, so when you mentioned workers, I was thinking on web workers, but you're not talking about web workers in the browser.
No.
Sending the message to some other server, and then that server is going to start doing all of this.
Yes.
Okay.
Correct. It's not web workers.
Thank you.
Which is not, I mean, it's good that you mentioned that, because you can also parallelize stuff using web workers. It doesn't hurt. So everything that you do client side, if you can do them asynchronously, then it's good as well. The only thing when it's on the front end side, you need to be sure that they are actually executed. I believe that it might be a little bit simpler to make sure stuff is happening on the server side, but web workers are great as well for specific things. If it makes sense.
I have a question. I was just slightly confused on the surrogate key part. I've never used a surrogate key before. Is that still, so you're validating or invalidating the cache by hitting like a CDN instead of hitting a server? Is that okay?
Yeah, purge by key, for instance. So I like Fastly is one of them. I like Fastly, so I'm going to show you on Fastly, but Fastly, it's varnish behind the scene. That's why I like it. But yeah, if you are providing a response with a surrogate key, then it's going to be tagged. And then you can say to Fastly, yeah, please purge everything, or purge only those keys. So you provide the service ID, of course, and your token. And then you can say, please, expire this key, for instance.
Okay.
And then they have the concept of soft purge, yes or no. This is exactly the same as stale while revalidating. So soft purges, they don't really purge it. They will serve a stale one and fetch the new one while they're serving the stale one. So this is cool. It should be enabled. Yeah. But yeah, this is to do that. This is just to tag the response. But it's at the end, it's really simple. It's you tag the response, and then you expire only depending on how you tag. That makes sense?
Yeah. And what does it look like? Yeah, it makes a lot of sense. What does it look like in like a CI pipeline or something like that? You just have like a step that's like, oh, these things changed, so fire off the Fastly purge request, or what does that look like?
Yeah, okay. Yeah, that's a good question. Of course, if you are running a build and you're deploying, you might want to clean the cache when you are deploying. Not necessary, right? For instance, the chunks here with Remix, they're going to change their name. So the name will be different. So still, you might want to purge the home page. So actually, this is what I was mentioning here. This is the event-driven cache expiration. It's kind of whenever you want. So yes, at the build time, it would be one good option, but then you need to have triggers. So for instance, with Crystallize, when someone is changing anything on any product document or folder and they are publishing it, we have an event. This event, what does it do? It is fetching the item that has triggered the event using GraphQL query on top of Crystallize, then pushing the payload, the result of this payload, to your endpoint. And on your endpoint, then you can decide to do whatever you want. And one of the tasks is probably to say, oh, okay, product 25 has changed. I'm going to tell it to Fastly and say, okay, please expire everything that you have for product 25. So the system has to initiate those events. You need to have events in your architecture that are triggered, of course.
Makes sense.
Yeah.
I may have missed it. Is this also something that like you can use Crystallize for like this, like message broker kind of work, or like when an event happens, is it subscribed to that or anything?
I would not say you would use it like a message broker, but you can use it. It might help you to avoid having a message broker in many situations, because we're providing that to you. Every time you have a new order, an update, a change in the state machine of the order, an edit on the product or on a content item or a subscription contract, you have events. So actually, you don't even have to do it in your code, which is kind of cool. Let's say you are taking the order, you get the Stripe payment callback response that say payment okay. You're going to push the order at that moment. Then you have a webhook set up to call another API endpoint. It's not even in the code. And you can set up two webhooks, two listeners, kind of. Let's say one is to push this order to Salesforce and one is to send an email. So, and this is why, to me, it's kind of true headless, but this allows you to be very decoupled from your service layer or from your application. Because, yeah, you listen to those events and you push those events somewhere else, but you don't even have a message broker.
Yeah.
Yeah.
Yeah, anything that can avoid that layer, I guess. It's really nice that you can have that all here.
Yeah. Yeah, and so yeah, but yeah, so many things to tell you about Crystallize. Like the content model is also really customized. So here we are really focused on product storytelling as well as the PIM, right? So you can shape, we're calling this shape. You can actually build the product that you want. You can have components on the product itself, component on the variant. You can create container shape or just document shape. This is just a banner. You can build anything that you want, and everything is exposed through the API. And I can tell you that the API is pretty fast. So you see, it's like 5 milliseconds maximum most of the time. And as mentioned before, we're handling CDN part of the image for you. So let's say I want to get, I don't want the price. This is the original image. This is not what you're going to use for performance, right? You want some kind of variant. So we're giving that to you. I don't know, you want the width and the height, and boom, you have you know, all the different variants for your image, different format, WebP, AVIF, and everything that you need. And of course, you don't have to build the components yourself. We have actually open source libraries that you can use to remove the friction, kind of. So here we have a component to render the image. We have a component to render the grid I was mentioning earlier, a component to render the rich text that we have. So it helps. We're providing the tooling, so it's really simple for you to build a React, not just build an app. It doesn't have to. The library mainly are in JavaScript right now, TypeScript even. But the goal is to provide even more kind of libraries. Golang, Rust, even PHP at some point, maybe. So yeah.
Very cool. Any support for, sorry, I'm probably just hoarding the question time here. But just a question around Crystallize. Do you have support for Markdown? I saw part of that schema had like rich text and these other types, but
No, no, it's no, it's not super for Markdown. I mean, yes and no, because the rich text actually it's just a text, right? So if I create a product, let's say create a product from here, or just a document. Let's create. I know I don't have the article, so let's create a product actually. I'm going to create a product, meetup swag. So I'm creating the product, and here I can have variant, but here this is a rich text, right? This you can get access from the API in 3 different formats. First, you can get JSON. Why? Because if you ask it for as a JSON, so you're going to get some structured JSON, like this is strong paragraph, this is ULLI. So you have a structured way of getting that information and JSON. You can get it in HTML, so you don't have to do the conversion yourself. You just render HTML from it, or you can get it as plain text. So technically, if you do this, you can ask the API to return that as a plain text, and then you've got your Markdown. And then it's your responsibility. Again, this is Headless API to convert this into Markdown. From Markdown to HTML or whatever.
Mm-hmm.
So
cool.
kind of yes.
Any other questions for Sébastien?
Maybe one quick question. First of all, really cool presentation. Thanks for that. You were quickly talking about application cache. I don't know if you mentioned it there, but one thing that the Remix team is also promoting a lot is Redis as like your own dynamic cache where you create your own caching logic. How would that fit into what you described so far with HTTP caching, and why is that something you didn't talk about?
I did talk about it a little bit, right? Application cache. I was using this. I didn't show an example. Yes, you're right, because the implementation of application cache, it's really up to you, and it could be Redis, it could be a database, right? It could be a MongoDB database or any kind of database actually, and you could have a Redis. And actually, it's good for me because then I can show you that in the boilerplate that I mentioned earlier that we're going to put in the links. If I go to the boilerplate and we go to this guy, actually, I'm going to go to this one. It's going to be way simpler. We are actually using Redis with Remix. So if you go there, you're going to get an example of that. And why we're doing this? It's to save the cart because we wanted to say that in Crystallize for this example, this boilerplate, we would push to Crystallize only the order that has been paid. That's an opinionated choice. And to save the cart while we're waiting for the payment, we're using Redis. So, and this is as simple as, I just need to remember what it is, storage. Yeah, so we get the storage. Of course, if you don't want Redis, you can transform that to a memory storage, but this is business as usual. You get Redis, you create your Redis component, and then you can just play with get and set from your loader. This is server side. So for instance, on this one, when we do cart placement, this is actually saving into Redis. So to answer your question, application cache, it's at the different level. And yeah, the implementation is less generic than HTTP cache. HTTP cache, we are on top of the protocol and the rules are clear, and it's way simpler for presentation to explain something that is a convention. HTTP cache, it's really up to you. You can do whatever you want. That's probably why I didn't focus so much on that, if it makes sense.
Yeah, that makes sense. So because you were, for instance, talking about user data, is that something you would then put into an application cache instead, because you said it's more complicated. You can do optimistic UI. So that's kind of the things you would cache in Redis?
Yes. If it requires caching, let's say, for instance, again, example with Crystallize, for whatever reason, the system is simple and we are handling the discount of a user in the customer directly. Like, let's say we have a metadata, discount something, and value 12%. So this is not going to change. You can request the API, you get it very quickly, boom, no application cache is needed. To me, application cache is really interesting when it removes computation, like the stock management. You don't want to do a query that is going to end up doing the sum and a complex query, something you cannot get right away from the server. In that situation, I will use application cache. And on top, a way to expire that cache as well, of course. To me, cache goes with expiration event somehow, because otherwise you are, if you want to be dynamic, you need to be able to expire the cache.
Okay, yeah, that was a really good explanation. Thanks, that makes sense.
All right. Thanks again, Sébastien. That was a really great talk. I think you were going to send me some links. I will post those to the group and also put up this recording on YouTube and post a link to that to the group too. Yeah, big round of applause again. Thank you so much.
No, thanks for having me, and see you around.
All right. Take care, everybody. Have a good one.
Good night. Bye-bye.
Bye-bye.